The data from exercise 1 are as follows. The estimated regression equation for these data is y hat equals 0.20 plus 2.60 times x. And then here's the scatter plot of the data together with the simple linear regression line. Compute the sum of squares due to error, the total sum of squares, and the sum of squares due to regression using the equations in the textbook. So first of all, the sum of squares due to error. And if we look at the scatter plot and think of the vertical distance between each data point and the corresponding location on the red simple linear regression line. So for example, for the data point x equals 1, y equals 3, that's the point in the bottom left corner, that's almost right on the regression line, and so the vertical distance between the point and the line is very small, and then when we square that distance we get 0.04. The next point along, when x equals 2 and y equals 7, that lies above the regression line, and if we calculate the vertical distance between that point and the regression line and then square that vertical distance, we get 2.56. Then the next point lies below the regression line. If we look at the vertical distance between the point and the line and then square that vertical distance, we get 9, and so on for the other 2 points. And then when we add up those squared differences, we get 12.4. Next, the total sum of squares, and if we add a horizontal line at the mean value of y, which is 8, so that's what the yellow line on the diagram is, and now look at where the points lie in relation to that horizontal yellow line, and again square those distances and add them up, that's what the total sum of squares is. Then the sum of squares due to regression is just the difference between the total sum of squares and the sum of squares due to error. And then the coefficient of determination, also known as r squared, is the ratio of the sum of squares due to regression and the total sum of squares. And that comes to 0.845, and this is more commonly turned into a percentage, and we say that r squared is equal to 84.5% for this data set. 84.5% of the variation in y can be explained by this simple linear regression relationship. If we take the square root of r squared, then we get the correlation between y and x, and we have to take note of whether the relationship between y and x is positive, in which case we take the positive square root, which it is in this case. If the relationship was negative, we would take the negative square root. But in this case, the correlation is positive and it comes to 0.919.